Crewton Ramone's House of Math. Look, I'm recording this from the beginning for a change. All right, so what did we do last time? Last time we talked about circles and regular solids and finding, right, the area of a circle, right?
Circumference.
And we found about circumference. You learned some math language. What's the circumference again?
The circumference
Yes.
is the edges of a circle shape.
It's the what?
It's like the edges of a circle.
It's the outside. It's this part. That's the circumference.
If you go around the circle, that's it.
Yep, that's it. That's called circumference. And what's circumference the same as? Remember you took your string and everything?
Circumference is the same as 3 and a little bit more.
Okay, 3 and a little bit more. I like it. We can say circumference is the same thing as 3.14. All right.
Yeah.
So, right, and that 1.5, you can remember, you can memorize that out. I've got students that have remembered it to 80 places for no apparent reason, but just because it's fun and you can be a nerd. But, you know, maybe a little bit more than that, maybe the next 2 or 4, but let's just 3.14. But if all you know about circumference is that it's 3.14, is circumference 3.14 or is that a different number?
It's 3.14.
Well, that's the definition of this term called pi. Right?
Pi. Yeah.
Because 3.14 is the amount of times the circumference goes around the diameter, right?
Yeah.
1, 2, 3, and a little bit more. Okay, so pi, that 3.14, is the same thing as the circumference divided by the diameter, right?
Yes.
Okay, that's what the 3.14 is, what you're talking about, is how many
Yeah.
times this goes around this. And the diameter, what's the definition of the diameter?
Diameter is if you cut the thing into a half.
Oh, okay.
How long it is.
All right. So if you go through from one side of the circle to the other side of the circle, now this is the important part, it has to go through the center.
Yep.
Right?
Yeah.
Okay. So if it doesn't go through the center, that doesn't count, right? You can't like that. It can't be like that. It has to go through the center. That's not diameter if it just goes through you know, like this, right? Okay. Okay. So then, wait a minute. We can tell more about the diameter. So diameter is from that side to that side. What do we call it when it goes from the center to the edge?
Radius.
Very good. So how many radii in the diameter?
How many radii in the diameter too?
Very good. All right. I'm starting over here, so let's put this more toward the center. All right. How's that look for? Yeah, you're good. All right. So 2 R's is 1 diameter, right?
Yes.
Okay, so then that means that we can do another definition. This is a review from last week. That means we can do another definition for circumference. Circumference, you said, was 3.14. Well, that's circumference is how many... I know what you meant. You meant that that's how many times the diameter goes around the circumference. But what's another definition for circumference?
What?
What's another definition for circumference?
Another definition for circumference?
Yes, in relation to pi and d.
Okay. The in relation to it.
Yes.
Okay, I don't know. Other than what I've said, I don't.
All right. Oh, no, that's good. You know what? I don't know is a fine answer, right? Rather than trying to make stuff up. And there's questions in mathematics where doesn't matter how much math you know, we still don't have the answer. And this guy named Richard Feynman told us that it's okay not to know. What's not okay is pretending you know. And then making up nonsense, right? But if you're still asking questions and trying to figure it out, that's fine. All right, so let me help you a little bit. I'm going to show you this. This is 18. Grab 18 out of your box. Yep, he's got his blocks right there.
There, I got my blocks.
All right, put it right there in front of you and look at it. They're going to examine this for a second. So now I'm going to say that 3 is the same thing. Can you see that 3 is the same thing as 18 divided by 6?
Yeah.
In fact, I can do this a little bit more and I can say that 6 is contained in 18. That's the drawing that I have here. 6 across, 3 down. The 3 doesn't go there. This is not, the symbols, that's not what we're doing. This is Mortensen Math or Montessori Math 101. So if I can say, and then if I was doing multiplication, it would be 6 times 3, and we'd be going up and the other way. But if I can say that 3 is the same thing as 18 divided by 6, then how do I figure out what 3 is? How do I figure out what 18 is? So in other words, over here, if this was 18, and that was 3, and there was a 6, how would I figure out what C is?
C is 18, right?
We're pretending, yes.
Okay, C is 18. To figure out that C is 18, you have to...
So, wait a minute, I'm going to put it over here in this diagram over here. Use my rectangle to...
36 divided by 2.
Oh, you're going crazy. Where are you getting a 36 out of here? What do you got in your hands? What's the most blocks you can have in this story?
18.
18, so... I'm going to say that my circumference...
6 times 3.
Okay, yep. So 18 is the same thing as 6 times 3? Absolutely, you're correct. So that would make this the diameter, and that would make this circumference divided by diameter, or diameter is contained in circumference, pi times.
Yep.
Right? That's the definition of pi. That's what we call that.
Yep.
Right? Pi is how many times the diameter goes around the circumference. And it's 3.14159.265. Bah, it goes on forever. Right?
Yeah.
Okay, so what's C then?
C must be 6 times 3.
Alright, or using your symbols over here instead.
It's... 18 divided by 6.
Oh, you said 6 times 3. In this case, what would the 3 be? Over here?
3 would be pi.
And what would the 6 be?
The 6 would be C.
Oh, try again. C would be the 18.
C would be the 18. 6 would be the... What letter is that?
D.
O?
Oh,
That's a D.
fine. What are you trying to say? D. How's that?
That's it.
Alright, so what would it be? Tell me. Speak the words.
Okay. 18 is C, 3 is pi, and then 6 is D.
Alright, so leave out the 18 and the 6 and the 3 and just give me the letters.
Okay.
So C equals...
C equals... So C is 18. It's D times pi.
There you go. Or, I'm just going to turn it around. Say it. Pi D.
Pi D.
Alright, so now, here's the next thing. Pi D. God, that's terrible. Alright, got it? It's not an O, that's a D. Right?
Yeah.
Alright, one more time. Let me just see if I can make a decent D. D. There you go. Alright, what's D the same as? Well, right above it says 2R, right?
2R.
So can I say that C is the same thing as 2, Roman numeral, pi, Greek, D. Oh, excuse me, not D, R. Which is our alphabet. English alphabet.
How did you get that?
And that's the syntax. 2 pi R. Isn't it?
Yeah.
Isn't 3 times 2 times... Well, let's just do it this way. We'll go this way. 2 times 3 times 4. Isn't that the same thing as 3 times 4 times 2?
Yeah.
Right? So what is it? It's no matter what. It's 24 no matter how I dice it, right?
Yeah.
Alright, so does it matter what order I put it in? Technically?
No.
Okay, but it's just math where we say we put this one first, then that one, then that one. So 2 pi r is your C. Do me a favor. I don't usually do this because you're a little boy, but take your notebook and a pencil and write all this down.
Okay.
We'll take a moment for you to write this down. Again. So, because repetition is the mother skill, and you're getting a good head start on your friends because most little kids, they don't get this. And I know...
fractions.
There you go. They're just working on fractions. You're getting some definitions of words. Because I know lots of college students, little boy, man-child,
Yeah.
that all they know about pi is 3.14.
Seriously?
Seriously.
I mean, you don't really need to know the pi tables if you just do it for fun.
Yeah, You kind of sort of do need to know it if you're studying mathematics, though. And if all you know about pi is 3.14, you're going to have a bad time.
If you're supposed to be a scientist studying.
Exactly. You're supposed to be a scientist, or if you're supposed to be a college student taking college, quote-unquote, algebra, or college trigonometry, or even geometry.
Yeah.
And all you know is 3.14, you're going to have a very, very bad time. And I run into students like this all the time. High school students, the only thing they know about pi is 3.14. They don't know that it's circumference divided by diameter, which means that they just memorize this, right?
Wait, don't I know that?
Yeah, well, you do now. In fact, you even have the experience of it, right? You took your little piece of string and measured it out, so there is no question that you know that pi is 3.14. Did you measure some of the other stuff in your house?
I was gonna do one, and then I had to do something.
You were gonna. In other words, you did not.
So yeah, I did not.
All right, but like I said, you could have spent some time, and that's usually a exercise for homeschool kids, where they go and, well, let's see. It works on this plate. Does it work on this cup? Does it work on this? Does it work on this? And you'll find out that yes, it works every single time. Doesn't matter how big the circle is or how small. Now, the one thing I like that you...
It has to be a circle.
Yes, it has to be a circle.
Oh,
But the one thing I like that you said, which is true, is that because you understand the relationship and proportion, doesn't matter how big or how small it is, this relationship is going to be the same, right?
Yeah, the diameter will get smaller and bigger.
Depending on the circumference, right? There's actually some calculus there. But the idea is that, yes, so that relationship is always the same.
Because then there would be nothing for it to stay the same up.
Right. And this is the point, is that that relationship remains the same no matter what. And we call that relationship between circumference and diameter pi.
Pi.
Now, there's a whole other thing we can do called tau, where we take the relationship, instead of circumference to diameter, we take the relationship of circumference to radius, but that's a whole other argument in mathematics, and you don't...
And one more thing to do.
Yeah, all right, so you're writing all this down?
Equals pi r.
Alright, so you know what we're going to do now? Last week I gave you the super, super simple definition of area, or how to find the area.
Just put lines in it and you get it.
Right, because basically all I did was I took this half and that half and turned it into a rectangle, right?
Yeah.
Okay, so then we got 1/2 of this, right? Times r, and you wind up with pi r squared, right?
Yeah.
Again, we have a rectangle of length times width, where one side is half of 2 pi r, right? And the other side is half of 2 pi r. And then this part of the rectangle, right? Because all we did is, I'm going to do it a much more complicated way. So you see I have those 4 pieces. Let's cut it up like this. Ooch. And let's cut it up like that. Ugh. But now we're going to have to go back into this other lesson on triangles. But if I take this, can you see that I have 1, 2, 3, 4 pieces? And a lot of times I'll make you do this. And you can take your pieces. Oops. That's supposed to be 1 piece of the pie. So let's say I have that one, and then I do this one, right? And then I do that one. So another one that doesn't have anything. In fact, you know what? I'll put an X, and then I'll take this one and put it there, and then I take this one. It's supposed to be pieces of this pie. 1, 2, 3. 1, 2, 3, and then I take that one, X, 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 and there'll be 4 of them, right?
Yeah.
Okay, so there's that one, and there's that one. Now use your imagination.
Okay. And do?
And you can see that the more pieces I use, the smaller these bumps are going to get, and the straighter this line is going to get. Do you see?
What?
Does that make sense? Because basically what I'm doing is picking these pieces up and turning it into this. So can you see that, look, I have half of it there and half of it there?
Yeah.
Alright, so I'm going to change this, and I'm just going to make this into a rectangle. Because if I make many, many pieces out of it, I'll have 1/2 of 2 pi r on one side, and 1/2 of the 2 pi r on the other side. What's 1/2 of 2?
1/2 of 2 is 1.
Yeah, so let's just make this simple and just make it pi r and pi r, right? So then I have pi r, and then this will be r. So the area will be pi r times r. What's pi r times r?
Pi r times r is...
What's r times r?
R times r is pi.
Oh, what's r times r? R times r. Don't make stuff up. You always try to make it hard. What's x times x?
X times x.
What do we call this piece?
X.
What do we call this piece?
X squared.
X squared. This is an x.
Yeah, that's an x.
Alright? So what are we doing when we do that? Well, I'm just saying that if I have x times x, or I could do this, that's the same thing as x squared, right?
Yeah.
Because this is basically x to the first times x to the first.
Yeah.
And then we just, what do we do when we have exponents like that?
When you have exponents like that, you...
How do they get the 2?
How do you get to 2? Oh, because you don't know what the x is, so...
Oh, stop. Quit trying to make it hard. How do I get to 2?
X plus...
Oh, never mind the x. We're just talking about the exponents. How do I get to 2?
1 plus 1 is 2.
1 plus 1 is 2. Why are you making this hard? Alright, now. I love it. You should see the look on his face. What's x times x times x?
X times x times x is 3.
Wait a second. Not just 3.
Oh, x squared 3.
Wait a second. Can you say it right? X to the...
X to the third.
There you go. And we could also say x to the third. We could also call that x cubed, right?
Yeah.
Alright. So what happens when I have exponents like that?
You add them by
I just
1.
add them up. There you go. Done. Okay? Simple math concepts, right? I didn't tell him that. You figured that out by just looking, right?
Yeah.
Alright.
It's kind of obvious.
Kind of obvious. Visually obvious. That's the beautiful thing about it. So that's how, and that's why we even call it a cube, right? And we did that whole exercise where we found the cubes, right?
Yes.
We did the 2 cube, and we did the 3 cube, and the 4 cube, etc., right? All the way to the 6 cube.
Yeah.
Alright. So now I can say, and now so I can understand that if I have r times r, that's just the same thing as r times r is r squared. So that area is pi, let's make this clean in here, pi r squared, right?
That's simple. Very simple.
That's very, very simple. Now we're going to do a more complicated one.
Oh.
Well, the idea is that you should know how to skin a cat more than one way. There's more than one way to skin a cat, right? You ever heard that expression? And by the way, it doesn't have to do with like the cats that you feed in your house. That's talking about the skinning a cat is mechanic lingo for working on the big Caterpillar tractors and so forth.
Oh.
And skinning it means
way more than one.
there's many, many ways to skin a cat. Anyway, it's not like you take a poor little kitty cat and take its skin off. That's no fun. Anyway, that's not where that term comes from. Anyhow, so there's more than one way. You don't understand it until you can do it more than one way. Simple as that. And there's multiple ways to come up with pi r squared. This is the easiest way, pi r times r, right? But let's get into it, and we gotta take a step back now, and see, we could do a whole lesson on finding the area and volume of cylinders, right?
Ooh, fun.
Yep. But did we not figure out at first that if I want to find the area of a shape like this, what do I have to do, Eddie?
You put like little slices.
Okay, sure, but I mean, what are the two things I have to know? Actually, I have to know three things.
The length and the width.
And one more thing. The length and the width and one more thing. What?
The height.
The height. That's it. That's all I need to know, right? Yeah. Okay, so once I find the length and the width, let's just do this for fun. I'm going to do a drawing here now. I'm going to say that this is, it looks pretty square to me, so I'm going to say that this is 3 times 3, and we'll call this 7, just for fun. So how would I find the volume of this thing?
Wait, so the width is 3, the length is 3, and the height is 7.
Yes.
And I'm trying to find the
volume. Yes.
So wait, perimeter or volume? Volume. So
volume.
I multiply the numbers together.
Alright, so tell me what it is.
Okay, 7 times 3 times 3.
Oh, why are you going to make it hard? What's 3 times 3?
3 times 3 is 9 times 7, 63.
Done. Why you got to make it hard? I mean, you could do 3 times 7 and get 21, and then 21 times 3, but 2-digit multiplication is not as easy as 1 digit times 1 digit, is it?
No.
But you're 100% correct that it's 3 times 7 would be just as good times 3, right? Would still give you 63. And I'm just saying, look, if I just do 3 times 3, which is 9 times 7, is still going to be 63, and that's just 9 times 7 is 60.
Put a 6, not a 3.
Yeah, I know. I'm going to put the 63 in there. And then I also got to make that 3 look like a 3 over here. How's that?
That's good.
Okay, so if I just find the area of this thing and multiply it by the height, I've got it every time, right?
Yeah.
Now, you could say that I could find the area of this, and the height would now be 3, right? So that I'd have my blocks the other way. So in other words, instead of having my box like this, I have my box like this.
Yeah.
But I'm just saying, keep the numbers small, and it keeps it easy and fast.
Very true.
Does that make sense to you?
Yeah.
All right. So now, what if I change the shape? In other words, what if I have a circle like that, and a circle, and then this? How would I find the volume again? Never mind surface area, we're just focusing on volume. Yes. What would I have to know?
I have to know the length, the width, and the height.
Okay, well, over here, we don't call it length times width anymore. What do we call it?
We call it circumference.
Oh, one more time. That's that going around. That's if I was going for surface area. How do I find the area of this thing? Because you're right.
It has its own language, but I forgot.
Oh, please, look at your paper that we just did, and you wrote it down.
Pi? No.
Yes.
Pi?
Times what times what? Gives me the area.
Pi times C.
We just wrote it down. Did you just not write it down?
2 pi times 2r.
Close. That's the circumference again. Don't get confused. How do I find the area of this thing? We just did it a second ago. What was it? It was pi r times r, wasn't it?
Pi r.
Because circles are hard to count and rectangles are easy to count. What was pi r times r?
Pi r times r is r squared. Pi r squared.
Pi r squared. And what's pi r squared?
Pi r squared?
Yes.
It is the
What was I doing? Why did I do all of this? Why did I cut the circle up in order to make it into a square? Or, well, a rectangle.
To find the area?
To find the area. So area is pi r squared, isn't it?
Yeah.
Okay, so now if I want volume, what do I need?
If you want volume,
you gotta find length times width times height is what you told me, right?
Yeah.
Okay, well in this case, isn't volume, what's length times width? Well, we don't call it length times width anymore, is what I'm saying. What do we call it? If I want the area of this circle. What's the formula for area of the circle?
Area of the circle is 2 pi times pi r squared.
There you go. It's pi r squared. Don't make this hard. Times what to find the volume?
times what to find the volume times pi r squared?
Wait a minute. I want to find the volume of this. I found the area of this. Now what do I have to do?
You have to multiply it
By what?
Multiply it by the what's it called? The circumference. What is that?
What are you doing to find the volume?
Height?
Height? Why are you making this hard? I don't understand why you're trying to make this hard. If I had this, this, and this, do I not just take the area up here and multiply it by the height?
You do.
Alright, is that not how I find it out? I find the area of this, and then I multiply it by the height.
Yeah.
So if I change my shape to a cylinder, what do I have to do?
Multiply it by the height.
Well, what do I have to do first before I multiply it by the height?
Find the area.
Find the area of this, and then multiply it by the height. How do I find the area of this?
By finding the area of this.
How do I find the area of a circle again?
You have to do 2 pi times r.
Okay.
Pi times r times r.
Pi times r, or you could just say pi r squared.
Yeah.
Alright, write this down in your book. Because isn't pi r squared just basically length times width?
Yeah.
Alright. Because rectangles are easy to count and circles are hard to count. Concept number 3. Good drawing. I like it. I can see your drawing. Now put the symbols in there too. Don't just make the drawing.
I know.
Alright. So area equals length times width.
Area.
But we don't call this length times width anymore. We call it pi r squared.
A equals length times width. I'm just going to put on the top.
There you go. And area equals pi r squared.
Okay, and then below that it says it also equals pi r squared.
That's correct. Pi times r times r. That's the dimensions of this rectangle if we cut this guy up.
Pi r squared.
Yep.
And then
Volume.
times the height.
Right, so all you got to do volume is one more dimension, because now we're in the 3D world, of length times width times height. Right?
Yeah.
Okay, did you write both of these down?
Oh, no.
You did not write both of those down. I can see you didn't write both of those down. Okay, if I'm writing, you're writing. That's the rule from evermore. Take a second and write them all down. I'll be right back.
V equals length with height. There, I've written it all down.
You've written it all down. Should I have some more tea? I'm going to have some more tea. Hold on just a second. Alright, so let's just have fun. I'll give you one to start. I was not going to do this, but you know what? Just while I'm making my tea. I want the volume of this thing. And I'm going to tell you that the radius... See, and I'm only going to give you 2 numbers. I'm going to tell you that the radius is... Oh, let's go with 3. And the... Ooh, isn't that a nice 3? And the height is 7 again. Just so you can get some practice multiplying by 7s. Tell me what the volume is.
The volume?
And I'll tell you what, in terms of pi, you don't have to multiply, you know, we figured out that pi is the same thing as 3.14, but you know what, we'll just leave it in terms of pi. So what's the area for this thing?
the area for that thing is
Just the circle.
R squared.
All right, so what's r squared going to be? I told you r is 3.
R is 3, so R squared is going to be 3 R squared.
It's just, what's 3 times 3? Again, you're trying to make this hard.
1.
Huh?
3 times 3 is 9. What
So
is
the area of this thing right here is going to be, that circle right there
Yeah?
is going to be 9 pi.
Well, then where do you get the other 3?
What other 3?
Oh, it's just squared. So, yeah.
Ah, okay. Now, what's 9 pi times 7?
9 pi times 7 is 63.
You can't just say 63.
0.14.
Oh, stop. You can't just say 63. The volume is, so I'll put it over here. Wait a minute, am I in the, I'll put it over here. The area of that thing was 9 pi.
Yeah.
That's the area. The volume of that thing is 63 pi, exactly, is the volume. You can't just say 63 because what's pi? That's multiplying by 3.14159.265 times.
Yeah.
Right? So if I actually wanted the volume, and see, this is a very accurate number right here. Right? 63 pi. If I want to round it off, I can say 63 times 3.14. You got a calculator handy?
Yeah.
Okay, well, punch your calculator and tell me, what is 63 times 3.14? Or you can use your brain and just do 3. Oh, well, where can I put that? I'll do it right here.
I'll just, use my calculator.
All right, lazy bones, go ahead.
Wait, I first need
3.14, 63 times. Or 63, 3.14 times.
Where is my calculator? Oh, on here? Okay, I have to go to my other. Wait, it still takes something.
You could have probably done it faster just using your pencil and paper than going to find your calculator. Just
okay,
saying.
I got my calculator.
All right, punch it.
My iPod.
All right, that'll work.
I need my calculator, thank you. Okay, and so the thing is what? What do I calculate?
Oh, you tell me.
63
Mm-hmm.
times 3.14.
Very good.
$197.82.
Approximately, yes. That's the same thing as 63 times 3.14, right?
Yeah.
All right. So we just found the volume of that thing. But usually when you take tests and stuff like that, they just leave it in terms of pi because that's actually much more accurate than what you have there on your calculator.
So you just do...
Because you knocked off all the other numbers, right? You just did 3.14.
Yeah.
Right? So you've left off a whole bunch of stuff.
Yeah.
All right. We've done that much. I think that's kind of fun. And now you can do any of them. Oh, here's a fun thing. What's my surface area of this cylinder?
And the height is 7, the area is 3. I mean, area is 9 pi.
Yep. So I know that this is 9 pi. And I know that this is 9 pi. What's this?
9 pi is 81 pi.
Oh, wait a minute. Are you multiplying or are you adding?
Oh, 18 pi.
There you go. Big difference between 18 pi and 81 pi. But now that's just the top and the bottom. What about this part? What about this part?
That part? Oh, that part, the area.
Yes. Okay, so use your imagination. Here, I've got this thing right here. Let's say that this is the thing that we were doing, right? I got this little toilet paper roll here, right?
Yeah.
And that what I told you, what this radius right here was 3, right? And this part right here is 7. So look, then I have to cut this open and there it is right there?
Yeah.
All right, so what's this part right here, going around?
Going around?
Mm-hmm.
That's 9 pi.
Oh, wait a minute, that was the area.
3.
Oh, that was the radius.
Oh, 20...
What do I call this thing going around?
The...
What's this, right?
Okay,
What's it called?
Circumference.
The circumference. And what's my circumference the same as?
Your circumference is the same as 3.1.
Oh, what's my circumference the same as? You wrote it down, little boy. Look on your thing.
Circumference? Circumference is the same as pi d.
Right, which was the same thing as 2 pi r.
2 pi r, yeah.
All right, so do you know what r is?
R was, R is 3.
All right, so what's my circumference?
Your circumference is 3, wait, yeah, 23
Oh, stop it. What's my circumference?
pi r. 6.
6 what?
6 pi.
6 pi. That's my circumference, because circumference is 2 pi r. I cannot believe that you're making 2 times 3 hard. But go ahead, I don't mind. So my circumference is 6 pi. Now, what was my height?
Your height was 7.
So what's the total area here?
Your total area was 9 pi.
Oh, stop it. What's my total area here? 9 pi was the area for the circle.
Here?
Yes. This part. This part.
Oh.
This part.
That part? Oh yeah, that part. I remember. It's 18.
Oh, stop again. What was this side right here?
9.
Oh, stop it again. What was this side right here? What does this say?
7.
7. Isn't that this side right here? Isn't that the height?
Yeah.
And what was the length?
Length was 9.
Oh, it was not. The length, the area up there was 9. What was that length right there?
Oh, the length was
The circumference, which was what?
6 pi.
What's 6 times 7, little boy?
6 times 7 is 35.
6 times 7 is?
6 times 7 is 43.
One more time. What's 6 times 7?
6 times 7.
In fact, does 43 appear anywhere? That's a prime number.
No, it doesn't.
So what is 6 times 7?
44.
One more time. Six times 7 is what?
42.
It is 42.
That's what I said the second time.
42. I didn't hear you. What? So why didn't you just repeat it then? 42 what?
42 pi.
There you go. It's not just 42, but 42 pi. And that's the area of this part, right?
Yeah.
Okay, because this is the circumference, and this is the height. And we figured out that the circumference was 6 pi. It's sitting right there looking at you.
Yeah.
And this is the height is 7. So what's my total surface area?
Your surface area.
Got to add up all 3 numbers. Don't fumble on this one. 9 and 9 and 42.
9 and 9 and 42. So 8, 60.
There you go. 63 pi is the volume. 60 pi is the surface area. And then we could do the math there, but we're not going to, the relationship between volume and surface area. All right, I'm going to give you another one. You got to do it all by yourself, no help from me.
Okay.
All right, you know what to do, right?
Yes.
Look, you've done it once. Is it going to change the next time we do it?
No.
All right, so tell me, talk me through, just generally, how do I find the surface area?
The surface area?
Mm-hmm.
So basically, you find the length, you find the width.
I'm going to give you that. So then what do you have to do?
Then you have to...
And it's not width, it's going to be the radius, right?
Yeah.
So think about how cool this is. I gave you 2 numbers. I gave you the height and I gave you the radius. I didn't tell you the circumference. I didn't tell you diameter. I didn't tell you anything. I gave you 2 numbers and you could figure out everything just with those 2 numbers.
Okay.
Because the relationship is always the same. So anyway, how do I find the surface area?
You find the surface area by finding the length, the width, the area.
Okay, so length times width and the area, and then what? The area of what?
Add the area together with the width.
All right, with the width. Okay, hold on a second. We need to organize your thought better than that. Don't I need to find the area of this, the area of that, and the area of this?
Yes.
Why are you making this hard?
Oh, you just have to find the three.
That's it. I just have to find the 3 areas. I'm going to find the area of the top here, right?
The area of the top, the area of the bottom, and then the area of the inside.
Right, the circle that goes around, which turns into a rectangle, oddly enough. All right, so I'm going to give you, all right, you're in business now. Oh, wait, and then how do I find the area of the top? To get more specific?
Of the top? Oh, you just square the number.
I just square the radius and multiply it by what?
You square it.
I square it.
Pi.
And I got to multiply by pi. Can't leave out pi. All right.
Square it and
Are you ready? I think you're ready. There we go. This is my cylinder. I want 2 things. Volume and surface area. Do you want a hard one or an easy one?
Easy one.
Okay, fine. Be like that. How about I tell you that this is 5 and this is 9.
Okay, first.
So my radius is 5. Ugh. Alright, I don't want to hear anything. Take your pencil and paper and go. Draw me a little picture and make your calculations. And leave the calculator on the side. We're going to do it in terms of pi, right? And then I can draw my picture where I roll the thing out and I have this and this. That'll give me my surface area, and this is going to be my volume.
9 and 5, right? The radius is 5?
The radius is 5, and we figured out the height is 9.
Yeah, the height is 9. So the volume must be... No. So the volume is 45.
45 what?
45 pi.
That's hugely important. You can't just say 45. But is that even right?
Yeah.
I have a serious problem with that. What's the area of this?
The area of it is 25.
Okay, so how are you getting 45 here?
Oh. Pi is right though.
Pi is right. Exactly, the pi part is right.
Okay. So if this whole thing is 25.
25 what?
Is 9.
25 what? It's not just 25, it's 25 what?
Pi.
25 pi, because area is what? Area is... Oops, I'm not on the thing. Put it down here. Area is pi times r squared.
Yes.
Alright, so what's r squared? 25. So 25 pi times 9 is never going to be 45.
Yeah. Oh, it's going to be like high. Like, it's going to be like really high. Like,
oh, it's not going to be really high. What is 9 times 25? If you got 9 quarters, how much money do you have?
225.
There you go.
The volume equals 225 pi.
Very good job. There you got it. All right. We're never gonna find that. We're never gonna do the other derivation of pi r squared. I'm just gonna give you. I'll give you a video to watch.
So surface area equals. Wait, I'm putting the other picture down now.
All right. So he got this one and figured out that our volume is 225 pi.
Okay. So wait, what are those numbers?
5 and 9. So I know my 9 goes here. Now, what's this gonna be?
Wait, I'm still writing it down.
Okay.
So now this is going to be, so I know that the top one, the top area is 5. The bottom area is 9.
I have a serious problem with both of those conjectures. What's the area over here?
The area over here is 5 pi.
Incorrect.
25 pi.
25 pi. That's correct.
And then down here is 81 pi.
How do you get an 81 pi? How did you figure that this is 81 pi? What two numbers do I have to multiply to get them?
The length and the width.
Alright, so I know the width is 9, right? Or excuse me,
Yeah.
I know the height is 9, or in this case that would be your width, I guess. So what's my length going to be?
The length is going to be
The
5.
the same thing as what? What's my length going to be that way? What is this going around here called?
The circumference.
Alright, so what's my circumference?
3 pi.
Try again.
3.14.
Hold on a second. What's my definition of circumference?
Circumference, your definition is...
Look on your notes. You wrote it down.
Your definition is... here it is. Your definition of... What again?
Circumference.
Of circumference is... Your definition of circumference, this is the wrong page. Your definition of circumference... What is it? Here, no. Here it is. Their definition of circumference is okay. Did I write this down?
You're gonna write it down. Where do you find where it says C equals?
C equals pi. C equals 2 pi r.
2 pi r. Write that down again where you can find it easily, little boy. Can you see that you kind of sort of need to know that?
Yeah.
Alright, so write it down again. You've got it hidden in your notes. Put it on the top of your page. Circumference equals what?
Circumference equals 2 pi r.
What's area equal?
Area equals
Of a circle.
25.
Equals what?
25 pi.
Okay, and how did you get that? I want the formula. What's the area? What's the formula for area?
The formula for area? The formula for area is you square it.
Alright, so what's the formula? Say it.
Formula.
Area equals what? It's
Wait,
even
what?
staring at you.
Okay. A equals 2 pi r.
That's still not good enough. What's this A stand for?
Area.
Equals what?
2 pi r. I mean pi r squared.
Pi r squared. That's where kids get confused because you're right. It sounds the same, right? Pi r squared, 2 pi r. Yeah, I can see how you can get confused. But can you see that this number and that number are two completely different things?
Yes.
Alright, so what's this length right here?
The length right there is 25. Or 9, I mean. No, 25, yeah.
How is it 25? That's the area. I want the length going around the edge.
The length going around the edge is 9 or 5?
That's the height. What's this part going around here called again?
The circumference.
What's the circumference equal to?
2 pi r.
What's r equal to?
R is equal to, okay, I know it's 3.
I just told you what the r was.
The r was the radius.
Which is what?
The radius is, I have it right here. The radius is 5.
Alright, so why are you making this one hard? What's 2 times 5?
2 times 5 is 10.
So why is that hard? 10 what?
10 pi.
Done.
That's the middle area.
That's just the length there is 10 pi. What's the area?
Oh, if the length is 10 pi.
And the height is 9. What's the area?
90.
Why are you asking it like a question? What's the area?
90.
90 what?
90 pi.
There you go. Say what you mean what you say. All right, can you finally give me the surface area of the whole thing? I knew we were going to get bogged down. Now we got to go next week before we can get to the...
104.
Oh, try again. 25 and 25 and 90 is never going to be 104.
124.
Try again.
Wait, 124.
Incorrect. 25, 25, and 90 is not 124.
140.
140 is the correct answer. Oh my goodness, little boy.
But what are the 225s?
The volume.
Oh. Oh. Oh.
That's what I want to hear. The volume of this thing as compared to the surface area of this thing, right?
Yeah.
Okay, so the volume was 225, which was the area times the height. The area of this circle up here, which we found using pi r squared, times the height.
Yeah.
Why are you making this hard? So I just got to find the area of this times the height. That gives me the volume.
Yeah.
And if I want surface area, I got to do three things. I got to find the area of the top, right, and the bottom. And then I got to find the area of the part going around.
Yeah.
Which means I have to find the circumference times the height.
Yeah.
Because I roll it out like this, right?
Yes.
And this top part turns into circumference.
Yes.
Alright. I think we're doing quite well. One more time. Circumference equals what?
Circumference equals 2 pi r.
What is area equal?
Area equals pi r squared.
Alright, and we are talking about circles when we do this, right?
Yes.
Alright.
Yeah.
So the circumference of a circle is 2 pi r. The area of a circle is pi r squared.
Yes.
Alright. I think we did a good job today.
Our time is running out.
I know, and our time is running out. But let's do, you want to do one more?
Yeah, sure.
Alright, you want a hard one or an easy one this time?
Medium.
Okay, medium and no help from me. What do you say?
Deal.
Okay. Alright, so we're going to change all these numbers, but now you know what to do, right?
Yes.
Alright. I'm going to leave these guys here for you. See, in my day, back in my day, when you took the SAT, they didn't give you all this stuff. You should know that circumference is 2 pi r. You're supposed to know that area is pi r squared. But now in the test booklet, they give you all this stuff up front. Right?
It must have been so much harder back then.
That's exactly it. I mean, these kids, they get all the formulas ahead of time. In other words, they don't have to know anything, and then they get a multiple choice test, and they still can't score well. It blows my mind how well they have dumbed down the American populace.
Oh my god.
You are not going to be one of those, right?
Wait, what?
I said you are not going to be one of those. You're my student. My students get A's and near perfect scores and blow people away when they take tests. Like I have this one student, she's been with me for a while, and she's like, "Oh, I'm doing great. I'm getting C's and B's." I'm like, that's not great.
Wait, D's are horrible.
D's are horrible. She's getting C's and B's.
Oh, that's a little better.
That's a little better, but it's still not good. It's better than F's, which is what she got when I met her, right?
Yeah.
But she's got herself thinking that, oh, C's and B's are okay. I'm thinking B's and A's, and when you get a B, you should be unhappy. Because you know this stuff, right? And I mean, she's not doing too much harder math than what you were doing right here.
F minuses.
Yeah, I know.
A's.
Most of my students, they get A's, and not just A's, perfect scores. Because once you understand the concept, unless they make an error in, computation or something, but once you understand the concept, they just do it over and over again and change the numbers, right?
Yeah.
Just like I'm about to do right now. Now, if I wanted to get all, make it a hard one, I would give you some fractions or decimals. But since you said medium, I'm just going to give you slightly bigger numbers, and we're going to keep them whole. So let's call this, let's make this a big thing. This is 9, and if that's 9, we'll say this is 27, just so we deal with squares and cubes.
Seriously, the time.
All right, you're on, you can do it. And you don't get to use your calculator. No calculator.
Fine.
Yep. All right, draw it and go. And this is it, then we're done. Our class is over. We never did get the derivation of pi r squared.
Can't use that, I can use this.
Yeah, just use it, just draw it, and you're doing fine. We know that okay, so I told you, the radius in this case is 9, and the height in this case is 27.
27.
Well, let me put that someplace where people can see it. Well, it is right there, but I'll put the numbers here. Radius 9, height 27. You go to town.
Okay, there. So now I want to figure out the volume.
Now you figure out the volume, then you tell me the surface area, and everybody's happy and class is over.
Well, the volume must be 243.
Holy cow, how'd you do that so fast?
Because 9 times 27 is 243.
Alright, well, we've got a serious problem here because it's not 9 times 27. What do I have to do to find the area of the top?
To find for the area of the top is 81.
81 what?
81 pi.
There you go. Times 27 is going to be a whole lot more than 81.
You have to do 81 times 27?
Oh my gosh! Can you do it? Yes.
Can I use my calculator?
No, you may not use your calculator.
Fine then.
Fine then, exactly. Just pencil it out.
Okay, fine.
81 27 times. Oh, come on, it's not hard.
Okay, 2 times 1.
And that's basically what?
It's really...
This is actually 3 to the 4th, and this is 3 to the what?
3 to the 4th, and that's 3 to the...
3 times 3 is 9, times 3 is 27. So basically this is just 3 to the 7th. If you knew that number, you'd be done. But anyway, what's 81 times 27?
81 times 27.
You're practicing your multiplication.
34, 30...
See, I count the big ones first, but go ahead. However you want.
37. No, more than that. Way more than that.
Oh, come on. 81 times 27? This is where you're falling down? You're falling down on the multiplication?
81 times 27 is hard.
Oh my goodness. Okay, fine. Let's count the big ones first. What's 20 times 80? What's 2 times 8?
20 times 80 is...
Or 2 times 8?
1,020.
Oh, stop. What's 2 times 8?
2 times 8 is 16. Oh, so 1,600.
There you go. So we did that part. Now, how many tens?
How many tens?
2 tens and 56 tens. So what's 7 times 8?
7 times 8 is easy stuff, 56.
And then 2 more tens?
2 more tens, 67, 7 tens.
Oh, stop it. What's 2 more tens and 56 tens? 2 plus 56.
2 plus 56, 58.
Done. Okay, we just counted up all the tens. Now, what's 7 times 1?
7 times 1 is 7.
Add them up, mister. And go this way.
Oh, first write that down.
I did write it down. See? We're doing all these granfalutin math concepts and you can't multiply. Without the aid of a calculator. That's why that calculator does not make you smart. Same thing. I can barely remember my own phone number now because I never call myself, and now it's all just push a button and it calls the person, right?
Yeah.
You don't have to dial the number. I mean, how archaic is that? But back when we used to dial numbers, I had 30 or 40 numbers memorized, right?
Seriously?
Seriously. I still know the number to my bank without thinking about it because the number to my bank hasn't changed. And all my friends that I've had since I was in high school, I know all of...
2,487.
How much?
2,487.
How are you getting 400 out of that? What's 16 and 5?
16 and 5 is 21.
That's the only action in the whole game. Easy racing. How'd you get 24?
800 plus 600 is...
We don't have 800.
Oh, 1,400. So bad.
So bad. And if you take 3 to the 7th, I think you're going to find that that's 2187.
Yes, it is.
Anyway, alright. So now we have figured out the volume was 2187 pi. Okay. Now we got to do surface area. I cannot believe that multiplication messed you up. So here's what you're going to do between now and the next time I see you. Is your mom around?
Yeah, I think she's over there.
Alright, so you get to practice multiplication.
Okay.
I'm telling you, fundamentals, fundamentals, fundamentals.
Okay.
Michael Jordan shows up for the, championship game. And it's going to be his, how many rings did that guy have? Anyway, what was he practicing? Free throws. What was he practicing? Bounce passes. What was he practicing? Right?
I mean...
Fundamentals is what he was practicing. So we can learn all this stuff at 7 years old, but the idea is you need to know how to multiply without using your calculator. And it should be easy. So think of it as a chance to practice your multiplication. Now you're going to get a chance to practice your multiplication and addition. So give me the surface area and we quit. We're going over time, buddy. Hurry up.
Okay. So, what are you going to give me?
It's the same problem. You got to find my surface area. So far you figured out the volume.
9.
And see, if I was really going to be a pain to you, I'd make you do the 2187 times 3.14 without using your calculator. But I'm not going to. We're just going to call it 2187 pi. Surface area! Surface area!
So here, like at the top left.
I got this, this, and that. So what do I got?
So, you've got, at the bottom, you've got...
What's the volume of this?
That's 81.
81 what?
81 pi.
Alright, so we got 2 of them. Now we just got to figure out this part.
That part, okay. This part. Okay.
What's my circumference?
Your circumference is 2 pi r.
So what's my circumference? You got it right.
Pi 1.
So I know that r is 9, so what is it?
9. 9.
That's my circumference is 9?
No, your circumference is 81.
Try again.
2 pi r. Pi. 81 pi, 9 pi.
How are you getting 81? What's r?
R is 9.
So?
9 pi.
Well, you gotta multiply the 2.
So 18 pi.
Why is that hard?
I don't know.
Okay, we've gone past threshold is what we've got here. So that's 18 pi. What's my height?
Your height? 18 pi is... Your height was 27.
Alright, do the math. What's 18 times 27?
18 times 27. Okay.
No calculator for you.
Okay, yeah, 1 times 2 is 2. So, 2 thousands.
Is it?
2,000.
It's 10 times 20. What's 10 times 20?
10 times 20 is 10 times 20. Oh, this is easy. 10 times 10 is 100. 110.
Oh,
No.
10 times 20. You've got 20 10 times. Try one more time.
300?
Oh, please. 20 10 times. You've got 20.
I already said 200.
All right. Then why do you keep changing your answer?
No, I said 200.
And that's what I'm saying. Why do you keep changing your answer? And then you changed it to 300, and then you said 2,000.
I said it 4 times, and then you said no.
I did not. I never once said no.
Well, it's glitching now, and I can't hear you.
Sure. Anyway, 10 times 20 is indeed...
Wait, what are you saying?
I'm saying 10 times 20 is what?
10 times 20 is 200.
Okay. Now, continue.
7. I mean, no, I'm not there. 10 times 20 is 200.
Mm-hmm.
And I'm doing 27 times 98. Right?
Mm-hmm. But wait a minute. Wait a minute. We already did 27 times 81 or whatever. You're doing 18 times 27.
Times 18.
Yeah. 27 18 times.
So, I know that it's 200.
Got that part. We did the 1 times the 2. Now what? How many tens?
There's 56. There's 5 tens.
Wait a second. There's 16 tens and 7 tens. How many is 16 tens and 7 tens?
16 tens, 23 tens.
23 tens. Good math. You did it nice and fast too. 23 tens.
There's 400
and then you got to do the 56 part.
480.
Oh, you got ahead of me. All right. Go ahead. 486. Boom. That's your surface area. Oh wait, we're not done. We got except for the part where that's the surface area of that part. We've got to add those 2 parts.
Right.
So what's 81 plus 81?
81 plus 81. Oh, that's simple stuff.
Good.
And it was 162.
All right. Now we got to add those 2 together, and we're done. That'll give me my total surface area.
62 and 4.
Then you say I'm going to have 1 extra one there, so it's not 5. It's going to be 6. That's going to be 4. That's going to be 8. Done. And we're talking about pi. Uh-oh. His computer just died. I can tell. They have one of those computers where if you leave it off the charger for an hour, it dies. Anyway, all right, there it is. And that was, we were done. We finished it right at the end there. But comments while my student is not here. 1, we went past the kid's threshold because he began making simple stuff hard, you can tell. Oh, look, he's back.
It just went black.
It just went black for a moment. I thought your computer died like last time. All right, so you see that my surface area was 2187 pi, and my volume was 2187 pi, and my surface area was 648 pi.
Yeah.
And we can see that volume compared to surface area, that's not very much surface area for a lot of volume.
No, it
very
much isn't.
And because of the circle, because circles hold a lot more. That's why most corrals in the old days were made into the shape of circles. Because if you had a corral and you wanted the maximum area for your animals, oh, you're glitching totally.
Yeah.
Yeah, but if you wanted the maximum surface area for or the maximum area for your animals.
It's glitching a lot, and there's only 1 charge left on computer.
All right, so we'll call it a day.
A little bit less.
I think you did a good job.
Okay, I'll get my mom.
Okay.
Before it runs out.
All right, quick, be fast. Be fast.
Okay. Mama!
Anyway, as I was saying, maximum amount of area for minimum amount of work, for a minimum amount of materials. Because if you're going to put fencing materials in, you're going to get more area in a circle than you do in a rectangle. Simple as that. So this is why you see corrals in the old days were circular. All right, I think you did a fantastic job today. You got a little overwhelmed in the basics when it came to like multiplication and stuff, but you understand the basic concepts. You now understand circumference and area. And next week we will finally get. Are we going to be together next week?
I'll ask my mom, because my mom is not here right now. She's on a walk.
Oh, they went for a walk. Has it turned nice there?
I think, yeah.
Yeah, because for a while there was just nasty weather. But anyway, all right. I will talk to you next week then. Fine job. Okay. So anyway, as I was saying, he was going over threshold because he was making this. This student tends to make stuff harder than it is anyway. But can you see where this is a classic example, because I've done this 1,000 times, and this is high school students, college kids. They get confused between 2 pi r and pi r squared. I mean, it's just right. So that's why you want to get their hands on it. That's why you want to do the exercises wherein they actually have to get their hands and measure out how many times the diameter goes around the circumference, so that they have the experience of it, so they can see, well, pi really is circumference divided by a diameter. And if that's the case, then 2 pi r, that's just pi d. And over here, finding area, we're eventually going to get to this, where I have, and if you go to module 4, I believe is what you'll need, the module 4 password, and hit the tab that says pi r squared right there on the tab, on the navigation bar on my website. There are multiple ways to derive pi r squared, and they're quick, fast, easy lessons actually. All right, I knew we were going to get bogged down because this is computation. We got bogged down in the computation. The concepts are easy, but the computation at that age is what was giving him a hard time. It wasn't the math, quote unquote, it was the computation, how we did the math. That's why I say computation is how we do the math. That's why you want to get addition, subtraction, multiplication, and division down. And what you're doing in elementary mathematics is you're learning those basic operations with various kinds of numbers. Whole numbers, fractions, decimals, etc. Radicals, right? Square roots and so forth. But it's just still those 4 basic operations. All right, CrewtonRamone'sHouseOfMath.com for more.